Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise. We're going to find the volume of a solid, and we're going to use the shell method to write and evaluate the definite integral representing the volume of the solid generated by revolving the plane region, which consists of three curves, in fact. And we're going to revolve this region about the x-axis, okay? So we have y equals 3 minus x line. We have y equals 0, which is the other name of x-axis. And we also have x equals 6 vertical line. At this moment, let's go back and see what the region looks like, even though you're going to see all the details within the video. So this is my green region, as you see. This is my green region, and the revolution is about the x-axis. And remember that we're using the shell method. And obviously, just by looking at the picture, we're going to get a nice cone after the surface, after the revolution, right? So as you see, like this, a cone filled inside. So we're going to find the volume of this three-dimensional object. So let me just remind you what the shell method is, especially when the axis of revolution is horizontal, which is in fact the case in our problem here. And here's a table that tells us the volume of the solid of revolution by the shell method. Depending on which axis you revolve around, you have two different formulas. But for the time being, we're more interested in the horizontal axis of revolution. So it's the first column and first picture over there. So essentially what we do is like we take a slice within the region parallel to the axis of revolution. Okay, so we have this like flat rectangle in the first picture, and we revolve that around. I'll just make it bigger. So to be able to write down the volume of the representative shell, we need the radius P of y and the height h of y, and the thickness is already dy because of the setup, because we use the shell method and the axis of revolution is x-axis. Okay, so the volume of the representative shell is 2 pi times the radius P of y, which is the circumference of the circle, times the height, that's the surface area of the shell, and multiplying that by dy takes you all the way to the volume of the representative shell. And if you go back, you can just see what the volume formula looks like. So here, since we are integrating with respect to y, we are interested in the y limits within the region. They are c and d in the first picture, as you see. So the integral becomes 2 pi times the integral from c to d, P of y, h of y, and d of y. So, all right, let's see how this volume integral is going to be shaped in our particular case, and we're going to also evaluate the integral at the end. All right, let's get started. All right, so let's start. We're going to use the shell method to write and evaluate the definite integral representing the volume of the solid generated by revolving the plane region surrounded by y equals 3 minus x. That is a line. We have y equals 0, which is the other name of the x-axis. And we have x equals 6. That is the vertical line. Okay. All right. So vertical line and the line are going to intersect, obviously. And why don't you go ahead and have your graphing calculator ready and graph y equals 3 minus x, and make sure you can see the intersection point here. So when x equals 6, y is going to be equal to -3. There we go. So please also see that y equals x equals 6 and y equals -3 is where the vertical line and the line 3 minus x intersects. Okay, so so let me just show you what I got here. You can pause the video anytime and you can use your graphing calculator to find the region. But what I got here is that I have only this this part of the region here because the question is asking like in the question statement it says like you have the region bounded by the x-axis, which is the purple line as you see, so purple line, and we have the blue line, okay, But also we have x equals 6 vertical line. Okay, x equals 6 vertical line, which is right here. So I can't get this part of the graph anymore. Okay, so that part is not included. All right, so the region, the green region mentioned in the problem is this green region here. Okay, there we go, this green region. So what we're going to do is to revolve this triangular region around the x-axis. Okay, so let's first see like what kind of region it looks like. I think we're going to get a cone. So let's see. We keep revolving that around. Okay, to get in fact a cone shaped three-dimensional object, and inside of that it's full. Okay, so it's a full cone. Okay, and we're asked to find the volume of that. Okay, by using the shell method. So in the shell method, we are choosing slices parallel to the axis of revolution. So here, the axis of revolution is the x-axis. Oops. And so right now, I want to revolve the slice around the x-axis and to see what kind of shell we're getting here. Okay, there we go. And there we go. Right, this is the shell that we get right after the revolution, and I need the radius of the shell, and I need the height of the shell. So let me just call the radius to be p of y and h of y. Okay, and this is already coming with the thickness dy. So in other words, I'm going to write the volume in terms of y, and everything is depending on y-related quantities here. So let's go back quickly and then check what kind of formula we had for writing the volume using the shell method. All right, so we're in the case of horizontal axis of revolution. So essentially, we have the revolution about x-axis. So you're looking at the first case here. So so all I need is to know the radius p, height h, so that I can write the volume integral as like 2 pi times p, which is the circumference of the circle of the bottom, times h, that's the surface area of the shell, and times dy, that's the volume of the shell. And we're going to integrate it from the y limits c and d. Okay, so let's go back to the problem and try to construct those quantities. One quick observation is that all the y's within the region, all the y coordinates in the green region are negative. So when I label this p of y as y, because I'm going to say that, let's say like this slice is y units far from the origin, I'm going to take it as like minus y, because the distance has to be positive, right? So since y's are all negative, negative y would be the distance of the very left end of the slice, or if, like the slice having the distance to the x-axis. So to make the distance positive, I have to go with negative y. That's the first observation here. Okay, so once you have that, and let's have the second observation here. So this distance from here to here, all over the region, is going to be 6. Because this is the distance between y-axis and the x-axis. All I need to know is this distance here for me to finalize getting all the quantities needed, because this is going to be p of y, right? And I only need h of y, okay? All right, so this is, in fact, this distance is the x-coordinate of this point right here, okay? So so let's try to come up with the x formulation here. Okay, x formulation of the line. There we go. Okay, so in other words, this is going to be x equals 3 minus y. Okay. And now this is, well, y is negative, so the coordinates here is going to be, the coordinates of this point would be y for the y entry, because that's what we picked, right? And for x, I'm going to replace it by 3 minus y. And y is negative, that's correct, right? Because it's below the x-axis. All right, so for that reason, this distance is going to be the x-coordinate, which is 3 minus y. That makes this h to be 6 minus 3 minus y, okay, because the whole distance is 6. So that makes it 3 plus y. All right. So the only observation here that is very crucial is that, first of all, this point comes with the coordinate, y coordinate to be exactly equal to y, and y is negative. But when I write the distance from the slice to the x-axis, that's exactly what the radius p of y is. That should be positive, right? Because it's distance, so I should go with negative y, right? And another observation here is that this point corresponds to y equals negative 3. And all the y's within the region are ranging in between negative 3 and 0. Okay, so let me just clean this part, and I want to write down the volume formula here. So volume of the representative shell is going to be 2 pi times p of y, which is negative y, times h, which is 3 plus y, times dy. And as I said, all the y's are ranging in between negative 3 and 0 within the green region. Okay. All right, I think we're all done setting up the volume of the representative shell and knowing the y limits within the region. We can go back and write down the volume integral as 2 pi integral from negative 3 to 0, negative y, 3 plus y, times dy. Okay? All right, let's simplify this. 2 pi, negative 3 and 0, negative 3y, minus y squared dy. Okay. Let's integrate or find the antiderivative in one shot. Negative 3y squared over 2 minus y cubed over 3. Integral from negative 3 to 0. Well, there's no integral, so we're just using the upper and lower limits. So we can use the fundamental theorem of calculus, okay? So we're going to plug in 0, but you're going to get 0 because y squared and y cubed terms are all 0, minus 2 pi. Now we're going to plug in negative 3. So negative 3 squared over 2 minus negative 3 cubed over 3. Okay, let's simplify this. This is already 0. So we have minus 2 pi. I have negative 3 squared, that's plus 9. So negative 27 over 2 plus negative 3 cubed, that's negative 27 divided by 3. That's negative 9. And negative times negative is going to be plus, so plus 9. Okay. All right, so this is going to be minus 2 pi minus 9 over 2, and that takes you all the way to 9 pi. Okay. All right, so that takes care of the volume here. So I can go back and look at this cone, filled three-dimensional object, right? Filled cone. So that comes with the volume 9 times pi. Okay. All right, I think that takes care of this whole question. This was a quite long question. I'm sorry, and we're done with that. And make sure you understand the setup here, like how I set the radius and the height. And that's the end of the video. Thanks for watching. I'll see you in another video. Bye.